Now, what we promised to achieve is a functioning tool, which is already functioning, could be improved, but it is already there, but possibly linked in some way to the risk data hub, which means improving the labeling and the definition part so that it is compliant with the risk data hub library. But we also promise to produce a list of requirements that anyone who has already a database or an information system can use with his or her developers in order to enhance the whole system. And this is what we have seen yesterday in our workshop with the Regione Lombardia, for example. They have their own system, RASDA, but they want to improve it, and this is the reason why they are working with us. What are the future developments? Where some were discussed already, so we will read Mia's deliverable on GDPR, because there is the need of a verification of data if we wanted to share those across different sectors. There is the need of securitization of some data, and we strive very much to get collaboration with critical infrastructures. So in the form of conclusions, I know that I gave you a very rough overview, but just 2 points. So what we are learning now during those days, that we are also having our internal meeting, that there are some hidden costs. They are not hidden, but the problem is they are hidden to the researcher community. They have not investigated so much. This is the waste. So we have a group in the project that is actually tackling this very important aspect. We think generally about the debris that are generated, for example, by an earthquake, but the problem is that we learn from the municipality of Modigliana, which is partner in our project, that also a landslide is treated as a special waste according to European directives. And this tells us something about the costs that are also associated with the compliance to the law. And the last point that I would like to mention, in order to have, as Mia said actually, in order to have enhanced data that can be used for a variety of purposes, the use cases that we are exploring, there is the need of coordinator of data. So there is the need of a more convinced investment in public administrations, in data management tools, and in enhanced capacity to work with developers to obtain the result that is expected. So I would like to give the floor to Xavier and Frédéric to react on what we have heard.
Yeah, well, do you have yet? I will try to begin. So, Shira, you were talking about the coordinator data. We need a coordinator. In fact, the way I understand it, and through the journey, as Kira said, I learned many things, and I come from the defense. So we are very straight defined systems, and this is not about knowledge enrichment, but about action and decision. So here we are not in the same field. And as Kira said, we need a coordinator of data. The way I understand it is we need a system to coordinate and to distribute the data. It is more than a coordinator. And in this system, one important aspect is about some data now, considering the existing systems and the existing data sets or the information system, say the tool and the software, there are some constraints which need to be overcome in order to come globally and collectively with a shared view of the risk. And in this way, there are several levels of maturity of organization. So in some, say, disaster waste management, the maturity is not very high, and it is higher in flood management, for instance, and because it has been managed for centuries. And so the way and the questions that are pertinent when you try to assemble data and to gather data. They may be completely different. And so the question is more, what kind of data do we need in order to be able to what kind of data would be helpful to improve the situation on a generally scale. And so Soteria, I have some much interest in Soteria because it dives into several fields, and especially the first field, which is data management on the technical level, and also the way to gather and to collect data by overcoming some constraints, some filters, silo, and also psychological or cognitive behavior of people. So these two have to be combined. And in more general, also the citizen have to be part of this dialogue to collect and enrich knowledge.
Thank you. I'll try to make a couple of comments, not synthesizing these two sessions because that's impossible in a few minutes. But so first of all, thank you for the great presentations, and they were really, really clear and enlightening. And I'll stop from the end probably. So first of all, it's really a great pleasure to see how behavioral science is integrated in this project. I think this is a really added value of this project, and I wish more projects would do the same approach, or you would use the same approach. And I mean, you really great presentation, great insights. So it concerns something that we already know. Our risk perception, risk awareness is still a key issue, a key problem. The messenger of the risk information is also a key problem. But there are many other things, and you touched upon several of them in a very clear and concise way. And I'm sure this has brought a lot of benefits to this project. Again, I hope this type of approaches, let's say, migrates to other projects like this. Also, Mia, your last comment was also very, very crucial, the way that you basically identified how the process started. Because, so the city wants to do investment in infrastructure, where to do that? Where's the problem? I don't have data. Who has data? So insurance companies have data. So if nothing else works, this is the only data that is available. My key view on insurance data, it is biased, incomplete, and doesn't cover the full picture, even for the clients. But in some cases, it's the only data. So you have to use it. And this process of data sharing is absolutely essential. And I had a question, which is, the process took 10 years. You think that it can be replicated in less time, ideally, because 10 years? Because 10 years above that. Yeah, of course, but 10 years is like... so I'm hoping that the benefits of the pilot can actually speed up the process, because I really think it's a huge, let's say, initiative, showcases the true value of these data, and also, as was presented in the first presentation, showcases the true value of structured data. Because what we see in the other parts of the non-insured data is that, data might be available somewhere. Someone has data, but in a completely unstructured way, which is almost unusable. So you have to process that raw data in a way that makes it useful. And the use of AI can only be if you use structured data, valid data, clean data, treated data, processed data. Otherwise, it's impossible to use raw data to establish any meaningful connection. I don't think we need AI to do that. Come on, those reports are really interesting. But we can do that without AI. You can use AI for much more powerful things if you have structured data. And then I come back to the first presentation on risk assessment. So I'm a civil engineer. I work in disaster risk management for the past 25 years. So risk assessment is my business. I'm an earthquake engineer by trade. So risk assessment in that field is way more advanced in certain aspects than in other fields, which is in fact how it started. The nuclear industry started to be worried about earthquakes, and the whole thing developed through that. I'm a firm believer that modeling is essential. I understand that modeling has a huge amount of limitations. It's not the limitation we had 25 years ago. Now we have way more advancements, but we still have things to advance, things to develop, things to be able to model. I think most of the non-scientific community is not aware of this. They think about can get you whatever result you want. This is not true. We can do a lot, we can model a lot of things, but there are things we cannot do. And on the flood aspect, this is one of the limitations. I'm sure you're aware that a flood will very unlikely destroy a building, but it will cause damage to things that are not the building, everything that is inside. Modeling that is extremely difficult. And this is one of the challenges in flooding, flood risk assessment, and flood risk management. But there are possibilities. There are things that can be done and can be advanced, for sure. For stores, extremely important. It's one of the fields where we know the least amount of things in terms of impact modeling, in terms of vulnerability modeling. It's probably the field that is going to grow a lot in terms of impacts over the next 2 years. I mean, in Portugal in particular, this is rising at a very high speed every single year. I mean, in 3 days, we had 3 storms. I mean, since Monday. Today is Wednesday. So to the end of the week, I don't know. It's the third one in 3 days, 3 different storms. So Ingrid, Joseph, and now Catherine. So these impacts are not neglectable. And we are not able to model them right now, simply because we haven't invested in the actual tools to develop those damage curves that were referred, which are basically vulnerability models. So this is a key part. For hazards, we are pretty much advanced. I mean, we know a lot about hazards. If you take away fire, that's a different beast. But for everything else, we are more or less capable. But from modeling the effect of the hazard into some physical quantities that just like damage, this is where things got very complicated from different types of hazards. Landslides is another one. We can do a few things, but not everything. We can model a few things, but not really 3 parts. So there's a lot of things to advance and all our research being dedicated to that. So this is my view. I'll say risk assessment is essential. It's a great tool, but there's a key point in the middle, which is damage modeling or vulnerability modeling, which we still lack a lot of knowledge. And my last comment on risk assessment was mentioned here as a tool to understand the problem. Absolutely true. It's also a tool to solve a problem, because when you do risk-benefit analysis, you have to do a second risk assessment with the effect of the solution. Or the multiple solutions. So you have to do multiple risk assessment with different solutions. And this is where then you gauge, well, which one is best. That's how it's done. This is easier to said than done, because if you have difficulties in modeling the actual problem, imagine the difficulties in modeling the problem with the effect of the solution. So again, a lot of things need to be developed on that end for different types of hazards, not just floods, wind, earthquakes, or whatever. So there's a lot of aspects that need to be developed, advanced. We have the general framework. So the first presentation was basically the general framework, which is absolutely correct, absolutely essential. We understand how to do it. There's a key point in the middle and here and there that we just need to develop more. And I don't think the research funding agencies understand that, because many of them think, yeah, we've been funding earthquake research for 20 years. Why we need more? But because we still don't know everything. And this will happen for the flood funding schemes. 5 years, 10 years from now, say, okay, we've been funding this for 20 years. I mean, don't you know enough? No, we don't. I'm sure we will not know everything. So we need to pass on this message that we need better modeling capacities, because empirical data doesn't have everything. It's essential, yes, but doesn't hold all the pieces of knowledge. You cannot just do cost-benefit analysis just based on empirical data. You just don't have enough information. Thank you.
Okay, perhaps one last point that I would like to add based on what both of you have said is that we need a validation also of risk modeling, and also the risk modeling after you have implemented the mitigation that was raised, and I always mention this, by the former Po River Basin Authority General Secretary, who told a room full of hydraulic engineers, your construction works, your mitigation measures, the structural measures are not really always effective. The design is good, but then if you implement them 10 years later, the river has changed, so it's not effective anymore. And so one use case that we want to carry out in the project with the municipality of Modigliana is to use those empirical data and the knowledge that is grabbed from the empirical evidence to support improved no-structural mitigation measures, land use and spatial planning, for example, where to rebuild. Okay, okay.
I just want to make a comment because I think it means a very interesting discussion. We can continue this conversation for a day. One thing that is emerging from my point of view is, yes, we need modeling, but what type of modeling we need? I mean, we need data which is interoperable at different scales, right? Because the decisions are taken and need to be taken in an harmonized and coherent manner from national, even European national, regional and local, right? The competencies and regulation are distributed. So we cannot envisage a model that will do everything, as you said. No. And we need to ensure that the modeling pieces are done by the experts that know this particular aspect, right? But then we need to make sure that those modeling pieces can be integrated, right? At the level where you need to make the decision. So we need a changing paradigm on how models are built. So they need to be built in a transparent manner. They need to be based on ontologies, which are shared, right? So that you can make these relations with the definitions. We won't change the definitions of the different themes or disciplines. They won't change. But we need to make sure that those definitions can be mapped at the proper level when you start integrating the pieces. So I think that's an important lesson that may emerge from both projects at the same time, right? And I want to recall that in 2024, the UN Statistics organized a conference with the National Statistical Officers, a global conference that is repeated every 2 years, because there is also a problem of how big data is incorporated in national statistics, right? So at the very end, we need to make sure that all data, I mean, it's not that we need to collect climate change data. No, we need all data which is available for decision making. It can be used for what we need to do for resiliency, for rebuilding better or whatever. And how this is shared, respecting actually what is the protection of data and so on, is another challenge. So we need distributed systems of curated data that incorporates all data, not just data collected for climate change. And we need a new way to ensemble models, right? So that if I go for one hazard, I go with one structure. But this structure is consistent, or the model pieces are consistent, ontologically meaning and semantically meaning. If I want to include 2 hazards or 3 hazards, so we can do a multi-hazard modeling, right? So I think this is the challenge. And this is actually what is emerging from the both projects. So it would be great if the both projects can raise their hands in the European Commission and say that very loudly, because otherwise we are going to construct systems that are top down and they may not be solving actually the problems at the ground level. And we don't have time to do anything else. And that doesn't mean that we can continue to improve things. That's not a problem. But if we don't improve things in a system that is consistent and can be integrated, then we will be doing a very poor job. So that's my conclusion from the three panels together. So thanks a lot for being here with us. Thanks.
So, can I add something to the morning sessions because it has arisen several times that we need data, we need modeling, just as you mentioned, but nobody has mentioned the exact answer to what kind of data we need, with what kind of model we need. If we don't have the total 100% replica of the physical world, then we cannot model anything 100%. And nobody has mentioned during the morning sessions that there is the digital twinning technology. And there is a process going on in Europe to digital twin the whole of Europe. And And that could give the answer to this question using historical data and any kind of data for the future, because climate change is about extreme things, El Nino, La Nina logic, intensifying the down and the upside. So the extremities, and you can feed in any kind of data to do foresight for the future and to make settlements and urban and landscape areas more future proof, considering disaster management. That's what I wanted to add. I'm sorry. Thank you.